Hi, my name is Yusuf Barsum, and today I will be explaining how to determine a sphere's speed at the bottom of the ramp as a function of the height and gravity. Step 1. Use a conservation of energy. We know that the ball's energy is entirely potential energy at the top of the ramp, and then at the bottom it's entirely kinetic energy. This is why finding a formula for the kinetic energy in terms of velocity, so then we can set it to the potential energy at the top of the ramp, so in order for us to solve for velocity. So here's the sphere, and it's going to be rolling down. This is mostly kinetic. This is entirely kinetic energy, actually. This is entirely potential energy, and this is height, and of course gravity is acting on the ball. Okay, next up, step 2 is finding the total kinetic energy. The kinetic energy of a rotating object is equal to the translational kinetic energy that due to the ball's forward motion, and the rotational kinetic energy, which is the kinetic energy due to the ball's rotation around its axis. This is equal to half mv squared plus a half I omega squared, omega being the angular velocity and I being the moment of inertia. For a sphere, I is equal to 2/5 mr squared, and omega equals to v over r. This shows that half iw squared is equal to this if you plug in the expression for I and omega. This leads to the cancellation of the r's and 2's, which leave us with half mv squared. So therefore, the total kinetic energy is equal to this expression formula, which is equal to 7/10 mv squared. So over here, see, when you multiply, these two cancel out, and these 2's cancel out. Okay, step 3, finding velocity. Because we now know the initial energy is entirely potential, and we can use the formula EI, which is initial energy, is equal to mg H, which is the potential energy formula, and it's equal to the final energy, which is the total kinetic energy, since it's entirely kinetic energy, which is 7/10 mv squared, which we found out in step 2. This leads to the cancellation of m's, which leaves you with 7/10 v squared gh. So over here, the m's cancel out. Then we can solve for v, which leads to the formula v equals the square root of 10/7 gh. And that's pretty much it. Thank you.